Okay, so now that we have the definition of a statistic being a calculation or a random variable only made using observations of the sample, we need to think about what would happen if we took multiple samples, or at least a different sample. There will be multiple values that that statistic can take. For example, if the experiment was to flip a coin and I had a sample size of 2, well, the mean number of heads obtained can either be 0 or a half or 1. Now, each of those outcomes have different probabilities, and that's what we'll be looking at now, the sampling distribution of a statistic. All of the possible outcomes of the statistic and the probabilities we would associate with those specific outcomes. When we produce the sampling distribution, it should look familiar. It's going to look a lot like a discrete random variable. Okay, so in this first example, we've been told that there's a large bag containing counters. 60% have a 0 and 40% have a 1. So I'm just going to write that as a probability distribution. Looks very similar to a discrete random variable. We've been asked to find the population mean, which is mu, which in this case we're going to find by finding the expectation. So just like we're used to with discrete random variables, we'll find the expectation of this distribution. So E of x is going to be each x value multiplied by its probability and summed together. In this case, that gives us 2/5. Okay, E of x squared, each of the x values squared, so that's 0 squared and 1 squared, multiplied by those same probabilities. And that's also going to give us 2/5. All right, if I want to find sigma, the variance, sigma squared I should say, the variance is going to be E of x squared minus E of x squared. Substitute in those values, and we get 6/25. So the population mean and variance, 2/5, 6/25. Okay, next we were told to list all the possible samples that we might get. So a sample of size 3 is to be taken. We just want to be systematic here. What samples can I get? I could get all of them being the same number, and we'll start with that case with all of them being zeros. Or I could have 2 zeros and a 1. And there's 3 different ways that that can happen. I can have 2 1s and a 0. 3 ways that can happen. Or I can have all 1s. And those are all the possible outcomes. Quite systematic, all of them being the same number. 2 of one, 1 of the other. 1 of the first, 2 of the other. And finally, none of the first. So just try and be systematic to generate those probabilities. Okay, so next we're actually asked to find the sampling distribution of the mean. So this is what I want you to do every single time, is to set out a table that shows these columns. The samples we're interested in, the probabilities of those samples, and then the actual statistic that we're working on. So this question's asked for the mean, but I'll also throw in a couple of extras. Okay, so I'll start by just putting in these different samples that we generated. I'm going to group them just so I can make sure that I've transferred them all correctly. And next to each sample, I want to find its probability and also what will be the statistic we calculated from that sample. Okay, the probability of getting 3 zeros, 3/5, 3/5, 3/5. I need the product of these. 2 zeros and a 1, 3/5, 3/5, and 2/5. I need the product of these. A 0 and 2 1s, 3/5 and 2/5 twice. And finally, all 3 of them being 1s, it's going to be 2/5 multiplied by itself twice. 2/5 cubed. So obviously, we could write these probabilities in shorthand, but I just wanted to show you the whole calculation. Okay, what is the mean of each of these samples? So for the first row, we'll get 0. For the next batch, they would all have the same mean of 1/3, and then the same mean of 2/3, and then finally a mean of 1. So I actually have all of the possible mean values that I can generate, and I have the probabilities that match each of those specific outcomes. I could do a similar thing with other statistics. What's the maximum value I can get for each of these samples? 0 and then 1s. What about the mode? What's the mode of each of these samples? So I've got 3 different statistics. Just going to work with the mean for now. Okay, so from here, I'm just going to regroup all of the possible means that we might have. So we only saw 4 possible mean values. Either the mean was 0, it was 1/3, 2/3, or we had a mean of 1. So for each of these, what's the probability that they occur? There was only one outcome that led to a mean of 0, and its probability was 27 over 125. The 3 outcomes that gave us a mean of 1/3, 54 over 125, 36 over 125, and only one outcome led to a mean of 1, which was 8 over 125. So this right here is the sampling distribution of the mean. The possible means I could get from my original distribution and the probability of each of those means occurring. Okay, so from here I can find the expectation of x bar, the expectation of the mean. And we use the same technique that we're used to using for discrete random variables. It's the outcome multiplied by the probability, and then we sum all of those products together. Okay, so the expectation of x bar is 2/5. Let's go ahead and find the variance as well in a similar way. So the expectation of x bar squared. Right, it's important that you're really labeling each of the calculations, setting out your work in a sensible way so that anybody can follow it through, and so you can check for mistakes in your own working. Expectation of x bar squared gives me 30 over 125. So we'll put that into our variance formula. It does simplify, it simplifies to 6 over 25. Let's put that into our variance formula. The variance is the e of x squared minus the e of x squared. We'll throw in some x bars for now. So that is going to be the 6 over 25 subtract 2 over 5 squared. 4 over 25. I think I can do this in my head. 6 over 25 minus 4 over 25 leaves you with 2 over 25. Okay, so that's the variance for x bar, the variance for the mean of the original distribution. Well, I did have 3 statistics altogether, the mean, the mode, and the maximum value. So I'll also do the sampling distribution for the mode, and I'll leave you to do the sampling distribution for the maximum value. There were only 2 possible modes. It was either 0 or 1. 4 outcomes led to a mode of 0, and the probability of those combined was 81 over 125. 4 outcomes led to a mode of 1, and their probabilities gave us 44 over 125. Okay, we'll go through a similar process to find the expectation, 44 over 125, and the expectation of mode squared. Once again, this also gives us 44 over 125. I hope you can see why this has happened in the last 2 cases. All right, let's just go ahead and calculate the variance. So the variance is expectation of the mode squared minus the expectation of the mode squared. Substituting those values, 44 over 125, subtract 44 over 125 squared. And in the calculator, that gives us 0.228. All right, so that's our expectation and our variance. So I want you to try and show the sampling distribution for the max value, so the maximum out of items that made up your sample.